Hello. Oh. Hi, my name is William Linton. I've been a developer, full stack developer for around 10 years now. And I wanted to use this video to demonstrate some of the things that I've learned over the past 7 years and some of the things that I really enjoy doing, a little bit of my programming style, so you get the feel for who I am and how I do things. For the past 7 years, I've been working for a company that does really interesting work. It's closed source, it's proprietary, so I don't have any code to actually show. So for that reason, I wanted to give a demonstration of how I would code some things, some of the types of problems that I've been solving at this job. So these are not the exact problems. This is not copying and pasting any code. It's just demonstrating my way of solving these problems as I would now with the experience that I've gained at this job. So my purpose is to protect the confidentiality of the company that I work for, but it's also to demonstrate my skills and kind of invite you into the way that I do things. So really appreciate you joining me. I'm really looking forward to doing this and solving some problems together. So let's jump into it. So what I chose to do for this exercise is sort of a spatial tree. Basically, the use case for this would be an application where really simple application where a user can kind of draw a rectangle on a map, like Google Maps or Mapbox or something like that. And then we would look for all of the, we would have a list of people or households by latitude and longitude stored in the app. And then once the user draws a rectangle, we would retrieve all of those points, all those data points that fall within that rectangle and return a list of them, maybe with their details, and maybe even display them on the map. And so the reason this is interesting is because when we get to large data sets, like for example, a data set spanning the entire US with, let's say, one data point for every household in the US, performance becomes an issue. And so there are some really cool things that you can do to start improving performance of your application in that type of situation. And there's a lot of ways to do that, but we're going to focus on kind of one simple way to solve that. And so I'm going to actually start with that approach, with that optimization approach. And then if we have time, then I will get to actually building a real simple application that will actually display some of that. But since the application code itself would be a little more basic, I wanted to start with the algorithm in case we run out of time. So that's what I want to do. And the algorithm I'm going to be using is kind of my own kind of custom version of a KD tree, and K being the number of dimensions. In this case, it would be a 2D tree, a two-dimensional tree, basically where you're partitioning your data set into smaller and smaller rectangles, and it lets you query things really fast. So I will explain more as we go along, but I first wanted to bring up a few limitations of this way. There's plenty of ways to do this. A lot of times people will do R trees or R star trees or things like that. I've done an R star tree in the past. I want to do something a little simpler because I think the focus should be on the thought process and not so much getting the exact algorithm correct. And also you can get really a lot of bang for your buck with some simpler implementations too. So the implementation I'm going to choose is something really simple. So I'm going to show you, I'm going to kind of draw a little diagram of what it would look like. And I have a canvas open here. So let's say we have our data set. And let's say this rectangle here represents, the area. Maybe this represents, like, let's say we have a country here, like maybe the USA. This is pretty bad, USA, but you get the idea. And let's say we have a bunch of points in here. And each of these points is corresponds to, like a household, maybe a household within the US, and it's not a polygon, but it's a point, which means it can be represented by just a latitude and a longitude. So there's a lot of ways that we could partition this data up, but the basic algorithm we're going to be using is basically splitting it up into smaller and smaller rectangles. So first we're gonna start by splitting it in two, and then in two again. So then we have 4, and we're going to continue splitting it up by 2s until we have a reasonable size, and then we're going to start splitting it up, each of these slices horizontally. That's basically my idea here. So that's a rough approach. Now there are some downsides to this. The reason I'm choosing this is because it's a very simple implementation. It does have some limitations, such as we're not going to preserve the original. We may be able to preserve the original sort order, but it's not optimized, meaning it doesn't find the optimal coverage. It doesn't try to reduce empty space within these slices, or things like that. So there's a lot of more optimized ways we could create these slices, but we're not going to bother with that. We just want something really simple right now. We're going to be using probably just the stock JavaScript sorting algorithm, or the sort method on the array prototype, which is really slow. Well, it might be really slow because we'll have to use it in a certain way. If I were doing this for a production code base, I might write my own version of a sort algorithm that takes in custom parameters, so it's faster. And one other thing is that we're not going to support expanding this data set after it's already created. We're not going to support adding or inserting records. So once the application loads, it just has a static data set, and that's it. Once the application loads, it's going to create this spatial tree based on the data it already has, and that's all that's going to be available for the lifetime of the application, or until it started again with the new data set. Just to keep things simple, I just want to show you my thought process. So that's what I'm going to be doing, and I will, as we go along, I'll kind of show my reasoning and my thought process for the decisions that I'm making. But let's get started. I'm going to start by, let's get into the project directory, spatial tree. So I'm going to create a Git repo, and then I'm going to create an npm project. And this is going to be called spatial tree. We don't really need to do any of this right now. Yes, okay. And I prefer to use esbuild. So we're going to use esbuild. I like to use esbuild because it's so fast. I prefer a quick iteration time. All right, so we are going to also start using jest. All right, let's create a new folder. Actually, you know what? Let's do a git ignore. I don't want to include node modules in my repo. Oops. Okay, so I'm going to start by creating a tests folder. Actually, I think what we should probably do, let's just start by creating a source folder. And in the source folder, we're going to do spatial tree folder. We can mix the test files in with the actual implementation files. So let's do a spatial tree.js. And also in a production database, or excuse me, in a production version of this, I might seriously consider using TypeScript for type safety. I'm using JavaScript for now because it's a lot faster. TypeScript requires a lot more typing, and it also requires me to make a lot of decisions about types up front, which can slow things down. So we're just going to stick with JavaScript. And so I'm going to do we are going to do, let's see, well, I'm going to do something like build. And at this point, this will change, but I also want to create a test file so we can immediately begin testing. Spatial tree.test.js. And I need to refresh my memory on the way to call jest from within JavaScript, since I'm typically using TypeScript. Okay, so we can, and I'm very used to TypeScript, so I need to adjust my, I'm probably going to need to adjust my export statement there, but we can get to that in just a second. So let's do, oops. And let us do, let's see what, oh, I'm getting confused here. Okay, so we don't actually need to include anything or require anything from jest, since jest will be the one finding all the files ending in .test. I believe we may have to set that up, but let's go ahead and write a test. Let's just go ahead and write a test that, oops, adds 1 plus 1. Expect to be, and I'm not entirely sure of their, yes, okay. Okay, so let's go ahead and see if that's working correctly. Well, actually, first let's add a script test jest npm run test. Cool. Cool, we got one to pass. Let's go ahead and make it fail and see what happens. Just to make sure it's hooked up correctly. Okay. It's hooked up correctly. Awesome. So let's go ahead and write our first test. So our API is going to look something like, we're going to have a build function that actually returns a spatial tree for us to use. And then we can make a query on that spatial tree. So, so what I think will happen is we'll have something like spatial tree. And this is going to be a prototype function. Oops. Prototype.query. We technically don't need, we probably don't need this. Okay, so our query is going to return some number of points, and it's going to take in it's going to take in a bounding box. The bounding box, and this we do want to be and since this is going to be geospatial data, I'm just going to go ahead and do lat long instead of x and y. Okay, so it's going to take in a bounding box and it's going to return a list of points. And for the point, we're going to have a, I'm sorry, the lat long is going to have a, it's going to have a southwest point, and it's going to have a northeast point. Now this, the point will actually have a lat and a long. So within each of these is an instance of this point prototype. And each of those is going to have a lat and a long. And so this is all you need for the bounding box. It's going to be just a rectangle, and it's going to extend from the southwest corner to the northeast corner. So that will have all the information we need to describe a rectangle on the map. And so this is going to return a list of points. So that's what our API is going to look like. And let's also, let's see, let's also do something like a flat list, because I want to compare the performance. So we're going to also do a flat list. And if we were using TypeScript, we would use interfaces. We would use the same interface for both our spatial tree and our flat list, because what we're going to do is we're going to call both from a test and compare the performance of them and see how useful our spatial tree really is. But since it's not TypeScript, we're just going to be smart about it and just make sure we're calling the same methods. So I'm going to go ahead and let's see. We can just keep it simple and keep this all in this single file for now. And we can just, normally if I was doing this in a production code base, I would break this out into separate files or figure out a clean way to represent them. I'm not going to waste time on that right now. So instead, I'm just going to do a flat list. And this is going to be super simple. All it takes in is a list of points. And it's going to store that list of points. And then when it queries, it's just going to loop over the entire array really stupidly and return all of the points that fall within that bounding box. All right, so let's go ahead and start writing our test. So let's say flat list returns points within bounding box. So let's do a flat list is going to be, oh, and we need to do flat list equals require, and we're going to include flat list equals new flat list, and we're going to pass in a list of points. So our points is going to look like, oops, and lat, let's do 32 and negative 90. Well, let's just keep it simple. Let's say 10, 20. Okay. Now, why did it recognize, oh, yeah, why did it recognize, oh, it's because I didn't export it. Okay, so can we fix that now? Just make sure it recognizes it. Cool. All right, we're going to pass in points, and now we are going to result equals flat list dot query. And we're going to pass in a bounding box. And we're going to pass in, oops, this is going to be a point. And let's say, let's make it really tolerant. So it's going to be like 0 and 0 and 0 to make it really obvious that it's going to fall within. And let's make this 40, 40. So we're going to pass in our bounding box. And we expect the result, oops. Expect result dot length to be 1. We also want to expect result at result at 0, lat to be 10, just to make sure it's the same points. And in fact, let's go ahead and do a utility method for that. We're going to be doing that a lot, the operation a lot. We're going to be comparing points a lot. So let's do a r points equal, or point 1, point 2, return point 1. We're only going to need it for the test because you're rarely going to be comparing actual. Hang on a minute. I'll explain in just a second. Oops. Oops. That's not what I meant to do. Yeah, so we're only going to be using this for the tests. It's very rare that you're actually comparing, that we would actually be comparing latitude and longitude to an exact number in this type of setting. We're mostly going to be doing greater than or equal to, because that's what's going to fall within a box. But this is useful for a test just to make sure because we already know what we're expecting, so we want to make sure that the correct thing is being returned. So let's go ahead and add this to our exports. That way we can collapse this to a single expect r points equal, and we can do result. Actually, the expected is typically first. I think that's correct. Let's see what happens when we run our test. Okay. So that's good. We haven't implemented it yet. In fact, yeah. This won't even run yet. We'll fix this later if this is incorrect. But first, we need to solve the problem that our flat list is not returning anything. So let's go ahead and return something. So let's go ahead and just return this dot points, because that's the simplest thing to do. We can fix it from there. Okay. So now we have. And also our second condition is actually passing, because there is literally only one point in the entire array. So let's do another test where flat list returns no points outside of boundaries, outside of bounding box. So let's do let's make this 5, 5. So this should not return anything, and this should be that. Now this will fail because we're not being smart about it yet. Okay. So let's just go ahead and do the logic here. So let's result equals array, and then for this dot points dot length, and we are going to say if so we need to compare, we need to make sure that this current point, the latitude is in between the southwest and northeast latitude, and the longitude is in between the southwest and northeast longitude. So we need to say if this dot points, let's just extract it out into a separate variable, point equals this dot point, so it'll be easier to refer to. And we're going to say if point dot lat is less than or equal to bounding box, or let's say greater than or equal to bounding box dot southwest dot lat, and we can do it one at a time. Can do longitude. Because if a point lies directly on the line, we're going to consider it within the bounding box. Otherwise, it would never be found by anything. Well, otherwise, it would never belong to any bounding box. Because we're not going to have our bounding boxes overlap. Okay, now this needs to be less than or equal to, and this is going to be northeast. Okay, and then we're going to add it result.push points, and then we're going to return results. All right, so let's see if that should get our second test to pass. Cool. Let's go ahead and add another test that just has 2 points, one within and one without. Let's just call it something like distinguishes between valid and invalid, or distinguishes between found and non-found points. Just to highlight the fact that so we're going to say 40, 40, and this is going to be 50, 50. Just to make sure it's smart. So this should be 1, and then we want we want it to find the first one. Okay. Now, ordinarily, if this were production code, I would be adding a lot more tests that check for edge cases and things like this. Like, for example, if it lies exactly on the line, we would be checking for that and all sorts of things. But we don't really have time for that. I just want to show my thought process. So it seems to be failing. It received 2. So it looks like we did something wrong. Let's go ahead and just console.log result. It's not doing my console log. That's too bad. I'm not sure how to get Jess to do that. Let's just see if we did anything really oh, of course. It's always nice when your error is really obvious like that. All right, cool. So all our tests are passing. So let's go ahead and switch over to our spatial tree now, and we want, okay, so let's, hang on a minute. Can we do describe, or how does that work? I like using describe to group my tests, but I think that's more of an it thing. Let's just see if it works. So let's say describe flat list. Okay, cool. So that works. So we've got our flat list working. Now let's go ahead and start on our spatial tree. And this should, what's nice is we can copy the tests for this for the most part because it needs to do the same thing. The API, as we mentioned before, is going to be exactly the same. Oops. Spatial tree, and now let's just do find and replace, and then let's also do it for our variable names. All right, let's go ahead and run our test. We should have 3 failed tests now. Good. So let's go ahead and start implementing that. Now, oh, well, first we have to import it. Spatial tree. Let's make sure it still fails. Good. I'm not sure why it's yellow. Doesn't recognize it as a prototype, apparently. Oh, I didn't, okay. Okay. It's because all right. Well, we can just keep everything in the constructor, honestly. Or it's fine. So let's say we're taking in points, because our flat list also does that, and that's how we're calling it. Yeah, so it needs to take in points, and then it needs to return the list. Okay, so as we take in points, we are going to assemble our spatial tree. Now, the interesting thing about this is the more points you have, the more times you want to divide it. The more times you want to divide your data set into rectangles. So that's going to be we're going to use a recursive function for that. There's not going to be a crazy number of levels because since we're dividing in 2 every single time, the number of rectangles is going to increase very quickly, and so we don't need to do a lot of iterations of the recursive function. So we don't need to worry about, like, you know, stack overflows or anything like that. So let's go ahead and say we're going to have our rectangles, And let's go ahead and define another type called rectangle. And this is going to be, well, actually we don't even need to use rectangle. We can just use bounding box. No, we do need a separate one because it's going to contain children. Yeah, so it's going to contain a bounding box, and it's going to also contain children. Okay. So as we take in points, we're going to assemble these rectangles. So we're going to do something like, okay, so first we want to sort our list of points by one coordinate. And so I think that's the key. That's one of the reasons I wanted to do this simple implementation, because we'll only have to sort one main time, and then we'll do a bunch of small sorts afterwards, maybe. So basically we only have to sort by one of the axes, and then I'm going to sort by longitude, and then because each longitude is half as long as a single latitude, because longitude only spans north to south, but well, I guess it doesn't really matter because it can be infinitesimally small, but I'm just going to choose, we're going to sort by longitude, or x, and we're going to sort once, and then we're going to start dividing that way. So let's go ahead and say sorted points equals points dot sort, and I think, let's just look up the MDN for this, just to refresh our memory. Array.prototype.sort. Sorts the elements of an array in place. Okay, so that's definitely okay, so this is a really interesting point. I'm glad it sorts in place because it's much quicker. It's not the thing you would typically do if you're using Redux. You usually want to have things immutable, but we're going for performance and speed right now. And so I'm going to leave it up to the calling code to handle that. I'm going to make it the responsibility of the caller to preserve their own copy of it and send us a copy. So if I were writing production code, that might not be what I would do. But we're going to do it here just for the sake of simplicity. And so we're going to use that compare function. We're going to use an arrow function, a, b, and we are I always seem to forget which one. Okay, so greater than 0, sort A after B. Sort A after B. If A dot lat A after B is greater than B dot lat, okay. So that's going to sort our points. And again, it's in place, so we don't need to do that. So now we have our sorted points. So we're going to go ahead and split it down the middle. So how are we going to do this? Let's do something like, let's see, we're going to have a, So our split, so we're going to have left, and we'll pull this out into a recursive function, but just to think through it here, I'm going to write the code as I talk. So the left is going to be, okay, so the midpoint lat. Oh, I'm sorry, I was going to sort on longitude. Midpoint longitude equals, and we're going to do points at 0. Okay, we're going to do points. Well, we can actually just do points dot length divided by 2 minus 1. And we'll verify that in just a second. And that would be longitude. Okay, so let's say, for example, our length is 4. Hang on a minute. We want to figure out... Okay, now just to be clear, I'm not splitting by space. I'm splitting by number of points on each side. So I want to make sure there's an equal number of points on each side. Because I want to reduce the amount of iterating we are doing over any given array within this structure. So that's why I'm getting the middle item. Now, it could either be the middle item or the 2 middle items if it's an even length array. So let's say middle item, and let's say points dot middle item index, points dot length minus 2, and that would be minus 1. So if there's 4 points, that would be 4 divided by 2 minus 1, which would equal 1. And so that would be the second item. So that's what I want. If it's the middle item exactly, well, hang on a minute. If it's 5 divided by 2, 2.5 minus 1, 1.5, that's going to be a float, and we don't want a decimal point after it. We want an integer. So we want to let us... What's the best way to do this? Let's do something like middle item index equal, or let's say, I guess what we can do is round up math.ceil So for 4, this would be 4 divided by 2 minus 1. So that would be 1. For 5, this would be 5 divided by 2 minus 1, which would equal 1.5, and that would be stealing to 2. So that would be the middle item in the array because it's the third item, and that's perfect. Let's just give a random, super random 17. So 17 minus 2 would be 8.5 minus 1. So 7.5 round up to 8. And again, that would be the middle item. Awesome. So this should work. And we are going to say that it's always going to be to the right of the middle item, meaning the middle item is going to be the last item in the left side. So we're going to say midpoint And we are going to say, let's say left, left max longitude, and then right max longitude equals middle item index plus 1. All right, so now we have 2. We have, okay. So now we can construct 2 rectangles. So we're going to say left rectangle is going to be a new rectangle, and for our bounding box, it's going to be a new point where our latitude is going to be, we'll just say 0 for now and we'll come back to that. But the longitude is going to be 0. Well, actually, we'll come back to that too. So, but we know that the northeast is going to be, the latitude is going to still be, well, that's going to be z. Let's actually go ahead and create those. We're going to say, oops, max lat. This is going to be max. So the maximum latitude is going to be negative 909. And then max longitude is going to be, yeah, same thing. And we'll figure those out in just a second. I just want to fill this out first. So the bounding box is going to be min lat, min long for the southeast, and or southwest rather. And for the northeast, it's going to be max lat, and it's going to be left max long. So that's the left rectangle. And the right rectangle is going to do max for the northeast, everything max for the northeast, but then for the southwest, it's going to be min lat and right, and this should actually be called right min long. Okay. Min lat, just to make sure that's correct. So min lat will always, so the latitude is always going to be whatever, the latitude is never going to change based on this. We're always going to keep the latitude as the minimum lat and the maximum lat. Actually, we are going to change that, but not yet. We're going to shrink it to the size of the data. We don't want any blank spots, but for now, we'll just keep it this way, just for the sake of simplicity. So now we have our left rectangle and our right rectangle. And so what we can do is we can create our parent rectangle. And this is going to be a new rectangle, a new bounding box. And actually, this is going to be just the whole thing. So the parent rectangle is going to include the entire thing, and now parent rectangle dot children equals left rect, right rect. Just make sure we're not throwing any kind of crazy errors here. Any syntax errors or anything like that. That's the one advantage of TypeScript. Or one of the advantages of TypeScript. Okay. All right, looks like we don't have any crazy syntax errors. We are seeing a console log now. Okay, that's cool. All right. So now we've got our parent rectangle with its children. And what I want to do now I want to go ahead and extract that. Well, hang on. The question is, should we go ahead and write tests for this first? No, I'd rather not. I'd rather stick with this current flow of thought. So let's go ahead and do a build rectangle. And this is going to be a recursive function. And this is going to take in a parent rectangle. And it's going to take in points, and it's going to take in start index, end index. Because we don't want to be allocating like an entirely new array, like a slice, every single time. It's going to get really slow. We could if we want to, I guess, but let's just keep it this way. I think it's my initial impression. Let's go with it, and we can fix it later if we need to. So let's go ahead and pull this stuff out into here, and we can actually call this split rectangle. And we are also going to take in a depth. Okay, so we're going to say if depth is greater than 0, then do all this stuff. If depth is greater than 0, then we're going to do all this stuff. And then we're going to call split rectangle on left index and so, okay, so we're going to have to modify this a bit, but we can I'm just wondering whether or not we should start writing tests for this. I think we're good for now. We're going to have to modify this. This is no longer going to be points.length. It's going to be end index minus start index. And I think we want end index to be exclusive. Let's start with that. So we're going to say end index minus start index and then we need to add that back to our start index and then subtract 1. Because when we were using the points.length, that was assuming that 0 was our base, but we no longer have that, so we need to add start index. So then we're going to say split rectangle left index, where we're going to pass in points, and we're going to pass in middle item index, middle. Oh, actually, no, this is going to be start index. This is going to be middle item index. And this is going to be depth minus 1. right? So basically what this is saying is, hang on, where's this left index? Oh, left rect. So what this is saying is go ahead and split this left rectangle. I'm going to pass in the original points array. I'm going to pass in, since this is on the left, the start index is going to be the same as the current parent, but the end index is going to be exactly in the middle, and then, which is the middle item index, and then the depth is going to be, we want to decrement that because we're currently processing one depth. We don't want it to recurse forever. So we also want to do this again for the right rectangle. And this time we're going to start with the middle item index plus 1, and then go to the end index. You know, yeah, I think we may need to. I think we're going to end up. I think we may have done the inclusive exclusive thing wrong, but let's just see what happens. So now what we can do is let's just start with a really simple number. Let's say split rectangle parent rect. And now that we have our parent rect, actually what we want to do is store it on this so that our query can look at it. Let's just look at the start and end. Oh, hang on a minute. We need to assign this correctly. Parent rect. All right, there we go. Okay, so the start index and the end index. The end middle item index. That does need to be inclusive. If that's inclusive, so let's say, for example, we have, this is being called with start. Start is at 10, and then end is at, let's say 22, or let's say 24, just to make it a little easier to divide. So we're going to come down here, and then our length here of the points is going to be 24 minus 10, which is equal to 14, divided by 2 equals 7 plus, oops, plus 10 minus 1. So that's 16. So 10, 11, 12, 13, 14, 15, 16, that's 17. That's 7. 17, 18, 19, 20, 21, 22, 23, 24, that's 8. Okay, I think we're okay, but we can come back to this. All right, so now that we've got our split rectangle, well, okay, what we do also want to do is we want to store start index Yeah, let's just keep it super simple. Let's store the start index and end index as well. Because that way, okay. Yeah. Because that way it'll make it really easy to query. All right, so let's just start by doing that. So we're going to store the start index and the end index. So we're going to say and let's go ahead and add it here on the parent start index equals right. Okay, so now let's go ahead and call this. So we're passing in a parent rectangle, we're passing in points, we're passing in 0, and then we're passing in points.length minus 1. And then we're passing in, let's just start with 2. Or let's just start with 1, really. So then we'll have a parent and then a left and a right. Just keep it super simple. Excuse me. And then our bounding box. Okay, so let's do our query real quick. So what we're going to do is a result for and this is going to be this dot parent. Actually, I also want to store the depth. Let's store the depth so that it makes this calculation easy. It should probably figure out the depth on its own. So let's just say it starts with 1. We're going to figure out the depth based on the size of the data set eventually. For now, we're just going to hard code it to 1. But we'll make that smarter. So we're going to say current depth equals this dot depth. And we're going to say while current depth is greater than or equal to, well, hang on a minute, is greater than 0, basically. Is that right? Because it has to process. Okay, so depth of 0 means everything just gets added to the parent. So it's going to be greater than or equal to 0. So while current depth is greater than or equal to 0, we're going to say we're going to have, let's say, our points. So I guess we can do it greater than 0. Okay, so here's the tricky part. Since we're passing in a bounding box, the bounding box might not correspond exactly to our splits, our rectangles. So it could be a list of rectangles. And let's, yeah, so a list of rectangles. And so then basically what we can say is, while current depth is greater than 0, if and then we want to do something like if the current rectangle for each of the current rectangle's children, hang on a minute. Well, actually, okay, so let's say rectangles initially is this dot parent rect, right? So that's the default. So if there was no depth, then the rectangles will always be this. And we can actually start with that. Let's start by doing that. And let's make that the simplest case. And then rectangles equals this dot parent rect. Or let's actually call that root rect, because there will always only be one root rect. Okay, so rectangles. So we're going to say for rectangles if, now here's where we're going to say if rectangles at I, if rect dot bounding box dot southwest Okay, so there's an easy way to do this that only requires 4 comparisons. So I think it is, okay, let's draw this out real quick. So if we have 2 boxes like this, oh gosh. I don't have my controls set up correctly, but anyway. So let's say we have a box like this. So what we want to do is check to make sure that southwest, northeast, so let's call this B, and this is A. So we want to say southwest B let's say x of southwest B is greater than x of southwest A y of southwest B is greater than y of southwest A. And then we want to say x of southwest B is less than x of northeast A and x of southwest B, and y of southwest B is less than y of northeast A. I'm not sure that's right. I mean, that does say whether this point falls within it, but we don't know if it's going to be the southwest point or the northeast point. Oh no, hang on a minute. It always will be, because if they're flipped, like if we have our A, if we have our A and it's like this, let's say it's like this, and this is our B. X, yeah, that's the problem. We don't know which one is which. I'm going to Google this. I know there's a simple way. I just don't remember what it is. So let's say check bounding box intersection. There we go. I mean, there's always Stack Overflow. Is overlapping 1D equals okay, so I guess what I was thinking was a point within a bounding box that's just for checks. So what we want to do is, so is overlapping 1D as a point within a bounding box. Is overlapping 1D box 1, hang on a minute. Oh, no, I'm wrong. Okay, I think what I was thinking is this. If southwest longitude is less than or equal to let's see. Let's just see how this would translate into ours. Create a new function. Do bounding boxes overlap? One or box 1, box 2. Okay, so So we're going to say x min 1 would be box 1 dot southwest dot longitude less than or equal to box 2 dot northeast longitude or box 1 dot northeast dot longitude is greater than or equal to box 2 dot southwest dot longitude. And then we need to do and then this is going to be all lat. Right? I think that's correct. Do bounding boxes overlap? I think we should probably write a test for that. So let's go ahead and write some tests. Do 10, 10, 30, 30, and then we expect do bounding boxes overlap, box 1, box 2 to be true. Pretty sure that's right. Cool. Let's do one that doesn't overlap. And then let's also do true if args are, but args are switched. So all these should pass. Okay, they all passed, which is great. So we can now use that. You know, I'm sure there's got to be some other situations let's try, I just want to see, no, I think we're good. I think we'll find out in our spatial tree tests if something's wrong, but I'm pretty sure that's correct. So now we can use that and say if do bounding boxes overlap, we're going to say rect bounding box, oops. Bounding box, and we're going to do rect.bounding box. If bounding boxes overlap, so I guess these rectangles are going to be the leaves, meaning they're going to be the ones that contain the most specific rectangles, like the smallest rectangles. Now, I don't think we actually need to have a list of points on each rectangle. If we have the start and end index, that'll be fine. So if two bounding boxes overlap, bounding box, bounding box, and we're going to say we also want a does point fall within bounding box, point box. And this is going to be point.southwest, or rather, no, point.longitude point.longitude and then we're going to loop over, let's change this to R so we know what we're iterating over. Now we want to loop over. And the reasoning I'm doing primitive for loops instead of methods is because the methods are actually slower. It usually doesn't make much of a difference, but we're going to be dealing with large numbers of things, and so it will make a difference. So we're going to say p equals rect.startIndex, and then p is less than or equal to rect.endIndex, and we're going to say does point fall within bounding box, and we're going to say points, this dot points at p, and then we're going to pass in bounding box. And we're going to say if this point does fall within this bounding box, then we're going to include it in our list of return results. So we're going to add this to points at P. And then we will return result. All right, so this is pretty complicated for a first run of a test after implementing it, but we're going to work through it. Okay, so spatial tree. So for one thing, we're not calling our query correctly. Oh, hang on a minute. That's not our query that we're not calling correctly. It's our depth. We didn't do the depth correctly. All right, so this dot depth. So spatial tree returns no points outside of bounding box. That's good. So we're not receiving any points at all. So let's find out why. So first thing I noticed is that current depth. Oh yeah, we're not doing anything with that. We're only oh, wait a minute. Spatial tree. Ah, okay. Yeah, so what's happening is that we're not assigning this if depth is, okay, so we need to assign this immediately because that needs to happen whether or not there end up being any children. So what was happening was it was hitting depth 0 and it wasn't actually assigning these, so they were both 0, I think. Yeah, well, yeah, they were both 0. So let's see what happens now. All right, let's see what's going on. So spatial tree returns points within bounding box. So we're receiving 0 for both. So let's check out our tests just to make sure we're doing things correctly. And I'm actually going to open up a new split here. I'm going to hide my mini map so it's easier to see. Appearance, show menu bar. What is? It's in user settings. Map, mini map. Let's turn that off. I don't really use it, and be able to see more code. So let's go ahead and open up our test file here. So our spatial tree returns points within bounding box. Spatial tree returns points within bounding box. So we're creating a bounding box, and we should have this point here. I wonder if it's because we only have a single point. No, that's not true because this one is also failing. Spatial tree.query bounding box. Do bounding boxes overlap? Okay, let's see what's happening in our split rectangle and in our rectangle bounding box. So here, Okay, let's just kind of step through this. Ordinarily, I would use a debugger. So I want to see, I don't happen to use the VS Code debugger. I typically use the debugger in Chrome DevTools, but I haven't started building that yet, and I don't know if that will work with the test itself. So let's see if we can. I wonder if our debug console. I'm not sure. Please start a debug session. Okay, let's go ahead and can we debug a test? That's what I want to know. Let's do this. Run and debug. Create a launch.json file. Node.js. So we're going to do node, or no, we're going to do just, in fact, we can probably just do this. I think that would work. Let's find out. Cannot find module. Type. Yeah, maybe this is not going to work. I guess what we could do, where is our just bin jet? No, that's not right. Just CLI. No. Let's try this. Let's do node modules just CLI, or rather, yeah, just CLI bin just.js. Actually, it might need to be just. Let's see if that works. Awesome. Okay, so I don't know the hotkeys, so let's just use the mouse. Step over, step into, okay, so that's pretty standard. All right, so let's do I'm going to step into this. So rectangles, root rect, this dot root rect, bounding box. Oh, you know what? No, never mind. Ah. Oh, okay, yeah, that's what it is. I never actually worked out the min lat and max lat. Okay. So we can kill that. Okay, that's good because that's not like a mystery or anything. I just forgot to do that. Great. So we can actually use our sort function. Well, now the sort function is supposed to be a pure function. So what I will do is after it's sorted, then we can go ahead and loop over and do p is less than points dot length, p plus. So now we're going to say const p, point equals points at p if point dot lat is greater than max lat. Oops. Then we're going to set max lat to point dot lat. Same thing with longitude. And then we're going to say max min. Okay. So we're just getting the entire bounding box of the entire data set. And I think that might actually cause our tests to pass, hopefully. No. Cannot read properties of undefined. Point, where are we? Does point fall within bounding box? Oh. This, reading 0, this dot points, oh, of course, we never actually put points on here. And you know what we might want to do? Yeah, I'm going to go ahead and just copy it. Because that's just respectful. That's just respectful to whoever's using your code. And that'll ensure that our tests don't get messed up in case we want to actually preserve the order in the test to make testing easier. Oh, all of our tests are now passing. Okay, let's go ahead and commit this. I have forgotten to be committing. So let's go ahead and get ultra simple spatial tree working with tests. Yes. All right, so I think what we want to do now is start adding some more complicated tests, such as let's get some nice data. In larger data set, or in medium size, I guess. I mean, this is not really medium size, but, and let's just do some crazy, you know, like that. And then let's do some of them that are inside and some of them are not. So we're going to do like, you know, like 50, 70, 80, 90, 30, 20, oops, 20, and then maybe like 0, maybe like 1.54, 333. So I guess what we can do is just count. Let's just count by hand how many of these are actually going to end up in the bounding box. And let's see, 1, 2, 3, 4, 5. We're looking for points where both of the coordinate values are lower than the corresponding coordinate values here, but also higher than these. And so let's add some negatives also. Maybe some negatives here, maybe like 1 here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we should have a length of 10. And I don't want to do this. Well, actually. Yeah, we could just, well, it's going to resort it, right? So we don't want to do that. Like it might not return them in the original order because it's doing its own sorting. I think it's a mistake that's working, that the previous test was working. Okay. Let's actually call this, oops. In slight, oops. What is going on? Oh, I have my slightly larger. So let's actually start to do more depth. Let's see what happens if we do more depth. So let's say depth equals 1. And then let's say current depth equals depth, and then while current depth equals greater than 0, then we want to we're going to loop over the rectangles, and we're going to find the children within those. Now remember, in our trees, a lot of times you have children that overlap 2 parents, but the nice thing about what we're doing is that will never be the case. So the algorithm for figuring out which they fall into is a little simpler. So all we really need to do is say current rectangles equals that, and then for let r equals 0, r is less than rectangles dot length, r plus plus. Okay, so we're gonna get the current rectangle. And then we are going to, I'm getting a little tired here. I may need to take a break in a second. So construct rectangles to length. Okay, I need to go ahead and take a break. This is a good stopping point. I need to clear my mind, maybe get something to eat, and then I will be back to continue.